summer seminar series. Today we have a guest speaker who is from our group here within the Marine Science Center, Laurie Weitkamp. She works in the NOAA Fisheries Science Center as a research fisheries biologist. She's not new to a lot of people here, but also new to a lot of people here. She has received 3 degrees, all from the University of Washington. She received her bachelor's degree in science, in zoology, a master's in fisheries, and her PhD in aquatic fisheries science. And she's going to talk to us a little bit about what's going on in the Pacific Ocean right now. Here for
So, I've probably given this talk 30 times in the last 6 years, and that's why it says the saga continues, because we had this thing called the Blob, which you can see right here, and I know I'm supposed to be close to the mic, and I'm not. And it is shaking up the North Pacific, and we are continuing to see fallout from the Blob. It's getting closer to normal, but it's still kind of weird, which is what the whole point of today's talk is. And given that I'm a federal employee, and there are other federal employees in here, raise of hands if you're a federal employee. Okay. I thought we would do a little civics lesson. So because we have federal agencies here at Hatfield, you might ask, what agency does NOAA belong to? You think of NOAA, but we're actually part of something. And what is this thing called the Northwest Fisheries Science Center? And I put in these little dolls there because I am the tiny little dot at the end. I feel like it. So the President of the United States has all these executive departments, right? He has a cabinet, and the heads of those are part of his cabinet. At least I think that's how it works. Here at Hatfield, we actually have several different of the representatives of these departments. So Agriculture, Commerce, EPA, and then Interior as well. I work for the Department of Commerce, which is where NOAA is. Secretary of Commerce is Wilbur Ross. And NOAA is just one of many departments in the Department of Commerce. And the big one you should see there is the Census Bureau, because next year, 2020, is the census. And it's been in the news a lot, shall we say. So, NOAA, which is the National Oceanic and Atmospheric Administration, also has a whole bunch of departments in it, and the one most people are familiar with is the National Weather Service. But there are actually all these other things as well. Here at Hatfield, we have the Office of Ocean and Atmospheric Research, which is all the people who do the vent stuff. And then we also have the Marine and Aviation Operations, which is MOCP, where the ships are over on the dock. And then I work for NOAA Fisheries Service, or used to be called the National Marine Fisheries Service, now we call it NOAA Fisheries. And that, of course, has its own departments. So these are the 4 main groups. We have regulatory programs, operational offices, regional offices, and science centers. Here at Hatfield, we have law enforcement. So if you come into the Berry Fisher building at the right time, you'll see the guys in their Kevlar vests who are out busting people for illegally harvesting different fish. And then we also have representatives of both the Alaska and the Northwest Fisheries Science Center here at Hatfield. And that's another story into itself. I work for the Northwest Fisheries Science Center. We are headquartered in Seattle, which is the main base, and Newport is our southernmost field station or research station. So there's about 300 people who work for the Northwest Fisheries Science Center. I should say there's about 2 million people who work for the federal government. The U.S. federal government is the single largest employer in the United States. So it's about 2% of the population works for them. There are 46,000 people who work for the Department of Commerce. What is it? I think it's about 12,000 who work for NOAA. The NOAA Fisheries is 3,000 or 4,000. Northwest Fisheries Science Center is about 300. And there are 25 of us maybe here at Hatfield. And I'm the only representative of my division here, so we're down to 1. Okay. So, Thank you for bearing with me. I just had to get that out of my system. What I wanted to do today is really start out and talk about these extreme conditions that we've been seeing across the North Pacific, the Blob, ElNinos, La Ninas, etc., and then spend a lot of time talking about the biological response to that, everything from plankton all the way up to mammals. Have just a quick section on forecasts, and then end with a quick summary, and then leave it open for questions. So before I do that, I'm going to be talking a lot about anomalies. If you don't understand them, you're not going to understand the talk. So if you have something like temperature that has a seasonal trend in it, around here it's cold in the winter, warm in the summer, anomalies are simply the difference between the current conditions, whatever you're measuring today, versus what it's supposed to be. Okay, it doesn't say anything about the underlying temperature, but negative anomalies, if you're using temperature, are below average, they're colder than they're supposed to be for that time of year. Positive anomalies are warmer than average. And just to illustrate that, this is sea surface temperature, and then this is, and with a actual sea surface temperature, all you can see is it's cold at the poles and it's warm at the tropics. When you look at the anomalies now, where red is above average temperatures, blue is below average temperatures, you can see, wow, it's really different. We've got, areas that are really warm, other areas that are colder than average, although it doesn't tell you anything about the underlying temperature. So we can have bright red in the Arctic up there, and you can also have bright red, somewhere in the tropics. They're the same degrees different from what they're supposed to be, but the underlying temperature is really different. It's obviously really, really cold in the Arctic versus the tropics, if that makes sense. Okay. So what I want to do is talk first about the physical conditions across the North Pacific and really these drivers. What is it that causes the physical conditions be as they are? Mainly the formation of the blob, and then ElNinos and La Ninas, and then illustrate that with these recent sea surface temperature anomalies. Okay, so how the blob formed is that normally in the winter we have these big storms that mix the North Pacific. So you get these really strong winds, and it's like a washing machine out there. And what happens is that heat gets transferred up into the atmosphere. You can imagine these really cold winds off Siberia over a relatively warm ocean. A lot of heat gets transferred, and then because you're mixing this, what had been relatively warm water with this cold, high nutrient water, you move heat between these two layers, and you also move nutrients up into these surface waters, and that prepares it for the following summer. So there's lots of stuff. You can have spring plankton blooms. What happened in the winter of 2013 and 14 is that we had this unusually high pressure event. They called it the ridiculously resilient ridge. So this is actually an atmospheric pressure anomaly showing that it's a high pressure. So this is the scale. This is above average pressure out in the place where normally these big storms are. And what happened is that we didn't have the strong winds, so we didn't get the transfer of heat up into the atmosphere. We didn't get the transfer of heat down with depth, and we didn't get the nutrients coming up close to the surface. That mixing just didn't happen. And so we ended up with this warm, low nutrient surface waters, which are called the blob, thanks to Nick Bond. And this just illustrates it. So this is sea surface temperature anomalies. You can see this big area in the middle that is very, very warm compared to what it's supposed to be. One thing that's kind of interesting is that last fall, those of you who were in the Northwest knew that we had just a killer fall. It was sunny. There was hardly any storms through most of the month of November. And so this is showing sea surface temperature anomalies in 2015 where we had the blob, and last November, and you can see that kind of got this blob going, and we also happen to have ElNinos at the equator in both cases. So it's kind of interesting to see this behavior happening again with this unusual ridge going on out there. Okay, ElNinos and La Ninas are the other big driver of our climate around here. These are tropical phenomena. They impact the climate or the weather around the globe. They're responsible for droughts and floods in different areas. And the way you measure them is that they're in 5 consecutive 3-month chunks, and it's measured as the sea surface temperature anomalies in this area here, and I realize this isn't very good. This is the El Nino 3-4 box. So this is South America over here. This is along the equator. Here's Australia right there. So they measure the temperature anomalies in that box. There's a whole series of buoys that sit out there, and they have probes that go way, way deep into it, and they measure them. So if you have, for this 5 consecutive 3-month periods, if the SST is over half a degree positive, it's an El Nino, and if it's below negative 5 degrees anomaly, then it's considered La Nina. And I'm going to say it wrong, I guarantee you. So this is the record then of sea surface temperature anomalies in this box, right there, that 3-4 box, going back to 1980, I believe, through the present. And the lines, the black lines, this is showing if it's above this line, in red it's a El Nino. If it's below this line, the blues are La Ninas. And you can see that in the last 40 years, we've had 3 big El Ninos, okay, the 82, 83, 97, 98, and now this 2015, 2016. Since that big El Nino, we've actually had 2 small La Ninas, and now we're back into another weak El Nino that is kind of unique in that it's really extended. It's been pretty long that they've declared El Nino with this current event, although it's not very strong. Okay, so those are what happens. And in North America, El Ninos and La Ninas have their biggest impact on our climate in winter. So during the winter, it tends to be warm. In El Nino winters, it tends to be warm across most of Canada and the northern U.S. And then this low out here causes the jet stream to go south. And this is actually probably classic what happened this winter. So California has been incredibly wet all winter long. We've got this weak El Nino going on. It's doing what it's supposed to. During La Nina winters, then kind of the opposite is true. The jet stream remains fairly high, and it tends to be really cold and wet here in the northwest and across the northern part of North America. So I like to say that La Ninas are great if you ski, El Ninos not so much. And then what's also interesting is that the one thing they do affect during summer is hurricanes. So when we have El Ninos, you tend to get more hurricanes in the Pacific because you've got this big mass of warm water out there, right? That's the classic El Nino signal. And in fact, in 2015, we had more hurricanes and named storms in the Pacific than ever before anybody knows of. I think there were 25 named storms in the Pacific. A couple of them came up here and hit the Northwest as well, which was interesting. During La Ninas, you have more hurricanes in the Atlantic and fewer in the Pacific, and it has something to do with the wind flow that I don't quite understand, and the fact that during La Ninas, then the tropical Pacific is cold, right? That's the signature event of that. Okay, so what does this look like? I'm going to show you a bunch of sea surface temperature anomaly plots. We'll start with this one, and you can see my cursor? No. Okay, so this is just a map. This is North America there. You can just see Russia across the Bering Strait with Kamchatka all the way down. There is a horizontal line that's the equator, and you can see South America, so that's just to orient you. And the color scale is down at the bottom. So things in red are warmer than average, things in blues and greens are below average. And in July of 2014, you can very clearly see the blob, right? This big mass of very warm, cold, or poor, low nutrient water was out in the middle of the North Pacific. Okay, as time goes on, then throughout 14 and into 15, now you can see the El Nino, okay, brewing at the Pacific, or at the equator. So we've still got lots and lots of really warm water throughout the northern Pacific, but now the equator is heated up as well. That continues, and you can see various amounts of warm and cool water, but suddenly we end up with cold water at the equator, and here's the first of these La Ninas. Moving on to 2017, here's our second La Nina, and then last fall, this is that blob that I was talking about, where we started getting blob-like formation because we wasn't stormy at all when it normally is in that time of year. This is the last couple months. And you can see now we've got this ElNino, week 1, at the equator. And then this is on Monday or Tuesday, whatever the 8th was. Today, the 11th. I believe it's Tuesday. And you can see the equator is still warm, so we have this kind of weak ElNino that's starting to fizzle out, but it's been incredibly warm across most of the North Pacific, or at least the northeast part of it, and especially up in the Bering Sea and into the Arctic as well. So a lot of hot water out there. And I think with all of these figures I've been showing, there's just not a lot of blue, right? I mean, there's a lot of red out there. Things have been very, very warm. And it's not just the North Pacific, as you can see from this figure, in the Southern Pacific as well, a little warmer than average. Okay, so what has the biological response been? What I'd like to do is show you kind of the extremes that we've been observing across the North Pacific, some observations from the Juvenile salmon survey that we conduct off the coast here, talk a little bit about adult salmon returns, because salmon go out into the ocean and basically sample the ocean, and how many come back and how big they are is actually a pretty good indicator of the conditions that they experience. And then I have one slide on marine mammals. And the take-home message is that there has been this huge response at all levels. It's getting more normal, but it's still kind of weird. And case in point, this is a tote of pyrosomes that we caught in a 5-minute tote last spring off the coast here. It's pretty staggering. This is a subtropical species that nobody had seen prior to 2016, and it's in huge, huge abundances. So weird stuff. Okay, so what were these extreme events? 2015 was really kind of the start of what we've been seeing, or at least that people were paying attention. We had tropical species off the Oregon coast. We had range extensions from California all the way to Alaska. Very, very dramatic changes to the food webs, especially the base of the food webs. We have the Newport line, maybe you've heard about, that we sample. I don't say we, Jennifer, wherever she is, samples, goes out there every 2 weeks. And the copepod community, which is the base of the food chain, the jellyfish were dramatically different than we'd ever seen before. We had a huge outbreak of pseudonychia. This is a diatom that releases domoic acid, which causes amnesic shellfish poisoning. It closed down fisheries from Alaska all the way to California for particularly razor crabs, but also crab fisheries. In our juvenile salmon surveys, we were finding a lot of very, very skinny juvenile Chinook and Coho, which we didn't think were likely to survive. So really, this is actually exactly what people think is going to happen with climate change. So we got a little preview of what's going on. When you've got warm water, a lot of stuff happens. In 2016, we continued to see weird stuff. The crab and clam fisheries continued to be closed. We still had dramatic changes to the food web. Anchovies, for whatever reason, decided to invade the Salish Sea. This is Puget Sound and Strait of Georgia, an area that they don't normally go into, but historically have, but they came back in droves. We ended up with these pelagic red crabs on Nye Beach here in Newport. Their previous northernmost known location was Mendocino. Normally they're found off of Baja, Mexico, and a whole bunch of them washed up on the beach one day. Pretty wild. And we had a huge squid fishery up here for California market squid for the first time. They caught over 2 million pounds of squid in Oregon for not the first time. Of that level, 2 million pounds. That's what you told me.
There were fisheries.
There have been fisheries of this extent, not that extent. Yeah. Huge fisheries. This is great, by the way. Yeah. Okay. 2017, one of the bright spots, we had these really large counts of lamprey over Bonneville Dam, which was very exciting because lamprey are a population that has been crashing. Again, we're still seeing, the weird oddity swordfish were observed off of Vancouver Island. This is when 2017 we really had the pyrosomes explode. These are sea pickles, yes. And there's some really cool stuff online that is from the Newport line. If you Google pyrosomes, you'll find some really cool videos of how dense they were. It was pretty amazing. Nobody had ever seen them this far north, and they were going all the way up into Alaska. We ended up with this extremely low Pacific cod abundance in the Gulf of Alaska. They closed down the fishery because the juveniles that were there when the blob happened did not survive. So you had really bad recruitment. And we continue to have clam and fishery closures because of domoic acid. 2018, the pyrosomes were thick in the spring, but then it appeared that they left in the fall. Zooplankton were returning to normal. There was a big hypoxic event off our coast here, so a lot of dead crabs ended up on the beach. Although the benefit is that the crabbing in the bay here is fantastic when you get the hypoxic event, so keep that in mind. We had a huge squid fishery in Oregon. Over 7 million pounds of California market squid were harvested here. We're still seeing warm water fish around in our surveys, and then we continue to have razor clam and crab closures due to domoic acid. So far, what I've heard about, it does appear that the pyrosomes really have left our waters. Perhaps they're down in California, but we had squid boats. In fact, I just saw one last night that's still in town here in Newport. They come up from California and have been fishing for squid up here. We're still seeing warm water fish around. This is some pictures of, I hope those are jack mackerel, that were caught in our juvenile salmon surveys a couple weeks ago. And then we still have closures for domoic acid, primarily in southern Oregon, northern California. I guess they just opened it back up again for razor clams, but it had been closed from Coos Bay down to the border, I think, with California. So a lot of weird stuff going on. Maybe not quite as much as there was, but still a little bit weird. One of the good sources of data we have are these juvenile salmon surveys that the Northwest Fisheries Science Center and jointly with Oregon State has been doing starting in the 80s, and then we restarted it in 1998 through the present, and we go and sample a series of transects from Cape Flattery up here, up the north tip of Washington, all the way down to Newport. Those dots are where we go out and sample. We fish with a big net. We do water chemistry and look at profiles through the water column and also take plankton. It's a big, huge effort that goes on every year. And we have this great time series then because of it. So this is going back in 1998. And what I've done is I have two slides. This is showing the invertebrates time series, and the kind of pinkish bars that are relatively light are just showing kind of the unusual blob period. And I should say this just came out in Fisheries. Cheryl Morgan over here is the lead author on this. And what you can see is that there's kind of winners and losers. Winners in the sense that things that had exceptionally high abundances during the blob and other things that did not. So again, I mentioned that the jellyfish community to really change. You can see sea nettles that used to be our dominant jellyfish out there really crashed and was replaced by water jellies, and we're seeing a lot more of these egg yolk jellies. Pyrosomes, we've never seen one before. The whole time series, and then suddenly they're pretty big there. And California market squid have generally been increasing and really took off during those years. And then we also had kind of what I call my the 2018 anomalies, things that are still pretty unusual. In particular, we got our highest ever abundances of California market squid. And they caught a lot of market squid out there last month, but the numbers are not, data has not yet been entered to know what the numbers will eventually be. As far as fish go, we see the same kind of pattern. There's some winners and some losers. This is really, for these three, hake, chub mackerel, and jack mackerel, this is essentially a recruitment, a huge recruitment event during the warm water, as well as the rockfish. You get tons and tons of little tiny rockfish. Pompano, Pacific pompano, are a southern species that come up when it's warm out. Of concern are catches of juvenile Chinook salmon and Coho salmon, because these have been shown to be pretty good predictors of the return of adults several years later, and I'll get back to that, but just remember this little graph there. So it's one of the lowest abundances we've seen for reasons that we don't entirely understand. So it looked like there were a lot of fish going out, and they just weren't there when we went to go catch them. The ocean. and we have some anomalies. So still high levels of pompano, relatively high levels of rockfish, and they were still catching this year pompano, rockfish, as well as mackerel. So, and one of the things to think about are kind of the ecosystem consequences of these. So if you have a big recruitment of mackerel or rockfish or whatever, when they're little, and I'm a salmon biologist, so everything is relative to salmon, they're great salmon prey, right? They'll eat them because they're small enough, but then they grow. And then as they're kind of age 1 or 2, then they become competitors with salmon. And so at some point they get big enough, and then they start eating salmon. Or they eat other things. So you start getting these big sucking noises, as I like to say, especially hake. So this is our single biggest fishery on the West Coast, is Pacific hake. They're very voracious predators, and that was a big recruitment event. So there's lots and lots of them out there. It's great for fishermen, but it's also a big sucking noise, right, of things that they have to eat to keep that population afloat. As I mentioned, adult salmon returns are really good because we count them very, very carefully. They're very valuable fisheries, and people want to make sure you're getting enough fish returning to freshwater to spawn, and so we have really, really good abundance data on them, and as well as size data. So it's interesting to see, and they go out and they go swim around the ocean and basically sample the ocean. And depending on how many come back, you know whether that was a good place wherever they were or not. In 2015, we really saw the first big dramatic change in salmon populations with record low returns to the Fraser River, Puget Sound, the Columbia, and the Washington and Oregon coast. And not only were they about an order of magnitude lower than anybody had ever seen before, but the fish were really small as well. The returning adults are small. And one of the concerns for small adults is that small females don't have very many eggs. Okay, and so the whole management is based on how many eggs you're getting back into freshwater. And not only did you not have very many fish, but they didn't have very many eggs per female as well. And they're now rebuilding populations of coho in those areas to kind of get back where they were before. 2016, we had the lowest pink return in Alaska in memory. And this is, again, this winners and losers. In the Fraser River, you had the lowest sockeye return on record, and at the same time you had one of the highest chum returns in the last 20 years to the same river. Sockeye and chum are different species. They eat different things. They go to different places. But it's pretty dramatic that these two groups coming to the river at the same time are displaying such different patterns. In 2017, there were big fishery closures off the Klamath in Northern California as well as up in Alaska to protect Chinook salmon. And then we got all kinds of weird stuff. So the highest Chinook, or excuse me, the highest chum in Alaska, and one of the lowest Chinook return ever. The Fraser had the second lowest sockeye and also very low pink returns, the lowest steelhead ever. And we also had very low steelhead returns to the Columbia River as well, and to the Oregon coast as well. It was interesting. In 2017, I had somebody come up to me and say, "Oh, the algae, the steelhead fishing, something's wrong with the algae." And I said, "It's not the algae, it's steelhead in the entire area." They ended up with, in the Fraser River, this is a huge basin that drains a big chunk of British Columbia. They ended up with less than 400 steelhead, as far as they know. So they emergency listed them under SARA, the Species at Risk Act in Canada, which is the U.S. equivalent of the ESA. It wasn't an algae problem, it was a coastwide problem. 2018, we had a big fishery closure again for coho. They were expecting low returns. If you remember 2017 in our ocean work, we hardly caught any coho. This was the return year. People thought, better pay attention to what's going on. Up north in Bristol Bay, they had a huge sockeye return, 62 million sockeye. I think it's the third highest ever that they've seen. At the same time, in southeast Alaska, incredibly low sockeye, pink, coho, and Chinook returns. Even lower steelhead and the lowest fall Chinook in 10 years to the Columbia River. What else have we got? And one of the bright spots, it was the highest shad count ever over Bonneville. Shad are an exotic species. They belong on the East Coast. They were introduced into Sacramento in the 1860s or something like that. And it has been the single largest return, anadromous return to Columbia, and they just blew the old records out. It was over 6 million fish. So far in 2019, so salmon are still just starting to come in. British Columbia took the extreme measure to close Chinook fishing throughout most of southern British Columbia to protect Fraser River Chinook salmon right now. This is huge. These are $1 billion, I don't know about billion, it's Canadian, right? $1 billion fishing industries, commercial, recreational sport. A lot of Americans go to British Columbia to go Chinook fishing. They closed it down. There's no fishing at all. I mean, this is like really, really extreme. And they're also expecting extremely low Fraser sockeye returns as well, which I'll talk a little bit more in a minute. They expect record low Chinook returns to Alaska and also expect perhaps record-breaking chum returns to Alaska this year. We'll see if these pan out. The fish are still out in the ocean, so we don't know. Right now, down in California, out in the ocean fisheries, they're catching tons of Chinook, and they're big Chinook. And I talked to the guys who do the research on Chinook down there. I said, what's going on? When is happening? And they're like, we have no idea why there's so many big Chinook. They think it's perhaps the highest return in perhaps a decade, and they're big fish, 20, 30 pounders out there, which is big because they're not going to come in until this fall, so they're feeding all summer long. We got an even bigger shad count. Last I looked, 7.3 million shad have been counted over Bonneville, so it's blowing that one out of the water as well. And we also have extremely low Columbia River sockeye and spring Chinook. And I mentioned this, I think that's my next slide. Yeah, so we saw this one coming, the spring Chinook return. In our juvenile salmon surveys, we know from genetic analysis that these are primarily Columbia River spring Chinook. There were hardly any of them out there. When they came back, this is the first year that these are returning as adults, and there's hardly any of them. Cause for concern, but we know that's an ocean problem. We saw that one coming. The sockeye, however, to both the Fraser and the Columbia River is really a tragic event, what I call my multi-generational tragedy. In that, we had this hot ocean, right, in 2014-15 when the Blob was out there, really warm ocean. That meant we had a really poor snowpack. And this is just showing snowpack in the western U.S. The red means there's less than 50% of average snowpack. And if I showed you the graph for Canada, for British Columbia, it would look exactly like that. Hardly any snow in the mountains. We record warm winter. That resulted in very low flows and very warm water in the Columbia. At the same time, we had this huge return of sockeye, the third highest return ever, but they come in this time of year, late June, beginning of July. They came in right at the wrong time, right when we were getting these huge increases in temperature. So this is 2015 versus probably a 20-year average or something like that. It's on the order of 3 to 4 degrees centigrade above normal. And you're getting, salmon really don't like temperatures above 20 degrees. And you were well into that. What happened then is this collision course, over 90% of the salmon died before they could get up to where they were going. And the eggs, the ones that did make it, their eggs were literally baked. So the egg viability was incredibly low. And what we're looking at now is that their offspring, the 4-year-old fish, are returning, and now you have the lowest return in over a decade. So they counted, I think it's 54,000 fish over Bonneville so far, and the run is pretty much done. So that's an order of magnitude below what it was, right? And that's exactly what they think is going to happen in the Fraser as well, because the Fraser had the exact same problems from this really warm temperature. So you can see this was a Blob event, but here in 2019, we're still being impacted by things that happened with Blob. It isn't going away, okay? Another interesting thing, I said I'd have a slide on marine mammals, humpback whales. In 2015, for the first time anybody knows of, They came into the Columbia River estuary. We think they were following anchovies, and so rather than eat out in the ocean, it was way too warm. They came in, and then in 16, they came into the Columbia and the San Francisco Bay. 17, same deal. 18, they were in San Francisco Bay, and there is a humpback whale in San Francisco Bay right now, but they think it's a sick individual that is escaping things. One of the consequences of this change in behavior, normally they're a little ways offshore, is that you've had all these entanglements with crab here. And they're talking actually about curtailing some of the crab fisheries because of these entanglements. Hopefully, the whales are further offshore now. Certainly the last year or two, we've been seeing them further offshore, and this will go away. Their behavior will resume what it normally is. Okay, so let me just end with a couple forecasts, the ElNino and sea surface temperature forecasts. So they just updated it. This is today's forecast. So there's an ElNino present at the equator, but they're expecting to transition to ElNino neutral conditions within the next month or two. And this is a graph showing, again, these are sea surface temperature anomalies in that ElNino 3-4 box. These are a whole bunch of models. This is kind of the averages of those showing what they think is going to happen. So we're here in July, and then looking out to the future. And this is our ElNino line right there. You can see that most of these models predict that the temperatures will cool in that box, that ElNino is going to go away. See if that happens. And then these are the forecast sea surface temperature anomalies for the period of August, September, October, November, December, and then this winter, December, January, February. And you can see there's still a lot of red out there, especially up here off our coast. We're talking 1 to 2 degree temperature anomalies, which doesn't sound like a lot, but it's huge for the ocean. Not good if you're cold water species. Maybe if you're tuna, it's a good thing. Anyway, to summarize, we've seen warm water present since 2014, still continuing across a big chunk of the North Pacific. We certainly haven't seen conditions where it's blue everywhere, like we were seeing a decade ago. This biological response has been huge. We're seeing effects, direct effects, as well as these kind of latent effects that are going to continue. For example, the Sockeye Returns, or perhaps this big recruitment of hake. The current ElNino and predicted above average temperatures across the North Pacific are unlikely to favor cold water species, things like salmon and crab, but they will obviously favor warm water species. And I think the big question is what's next. So with that, I forgot. So we're having a cutting party and you all are invited. So the juvenile salmon survey that I was just talking about, we go out and we catch salmon, we measure them and put a tag on them, we put them in a bag and we throw them in the freezer. So what we do is we get a whole bunch of people together and we go and take parts off of them. And this is 20 people, 25 people in a room dissecting fish. It's a big assembly line and we can really use your help. And I have sign-up sheets, 3 days if you'd like to sign up.
It's a huge party.
It is a huge party. We ask that you come for a full day. We will teach you everything you need. We'll provide you all the cutting gear, aprons, gloves, etc. It's a great opportunity to sit next to a professional fish biologist or other plankton person and sit and talk to them for a day. Not that plankton people aren't bad, but you all know they're just a little different. Yeah, so we ask that if you're going to come, please come for a full day because it takes a little while to get up to speed. But if you've never experienced a cutting party before, I encourage you to come because there's a lot of fun. So with that, I will open it up for questions. John, I knew you were going to.
So the ElNino La Nina, half a degree centigrade difference that we're talking about, how closely correlated is that to say, the global climate change phenomenon? Is this a threshold thing, or is it sort of marching along right along with that?
So for the last, I just saw a graph of it, and I almost grabbed it, and I didn't. Every time we have a ElNino, we tend to have exceptionally warm global climate temperature. So they're correlated. And you can imagine, with all that warm water in the ocean, it heats up the entire planet. So the ElNinos are associated with warmer than average years across the entire planet.
So,
So
you're not a climatologist, but it's not ridiculous to guess that it might be possible to just lock into a constant El Nino conditions with very small change.
I think it's too dynamic for that, but certainly the marine heat waves, which is what they're now calling the Blob. I think some people didn't like the name of Blob. Marine heat waves, and there's actually a new paper that just came out describing, and they're now categorizing marine heat waves, and looking at the pattern of those, and finding that the frequency of marine heat waves is going up, and they're becoming more frequent, as are El Ninos. So the expectation is El Ninos should become more frequent and more intense in the future as our fertile planet gets warmer. Yes. But it's too dynamic to get locked in. I mean, we do get locked in for short periods of time, but you got to think, I mean, we're on a spinning globe, right? It's a very dynamic planet. It's a big ocean, and ocean water can move around anywhere it wants. There are continents, but the ocean is huge, especially the Pacific. Yeah.
Other questions?
Yes.
I was just curious what's that big spike in shad coming back. So they're not native. Do they compete with salmon, or is there any concern?
We
about
really
that
have
being
no idea. Yeah. So I think they probably could compete with salmon. We don't know what they eat. We don't even know how many spawn below Bonneville or go through the locks instead of over the dam. That's just the ones that are counted going through the fish ladder. I was up in Cascade Locks, which is above Bonneville Dam, and it's a blast. You go up there this time of year, and they have an actual old locks, the Cascade Locks, because there was little rapids. There's a lot, and there's all these people fishing for shad, and I guarantee you, every 5 seconds, somebody will pull a shad out of the water. And this lady I was talking to, and she's like, I don't know what's going on. You know, we were here the other day, the limit is 50 shad, right, a day. And I don't think there's any seasonal limit at all. Half the people are of Eastern European origin, and they eat them, and then the other half use them for crab bait. So tell me something about shad. They apparently have all these little bones in them that don't look like fun.
They
But
can them. The bones
exactly. Yeah. But she said that they could get their limit of shad on days that there were 0 counts at Bonneville. And I think a whole bunch of them come through, they just go through the locks. So who knows what the real numbers are. Yeah, we have no idea. And I think it's a huge issue that nobody's really addressing very well. They're planktoners, but who knows? I mean, so they're related to sardines and herring. They're in the Clutia date. Yeah. But big question. Yeah.
So is ODF&W looking at the shad fisheries?
Not really. Yeah. I mean, they're kind of trash fish around here.
Uh-huh.
And yeah, nobody's really doing anything with it, but I think they really should. I get more, when I fish in the estuary, the Columbia River estuary, I mean, we get zillions of shad that are rearing in the estuary that potentially are competing with salmon. Who knows what they're doing at all? Nobody knows. So, yeah. But it's huge. Yeah. Other questions? Yes.
Quick one. With the sockeye returning during the blob that ran into like the hot river temperatures, were those river temperatures blob related?
So they were because the warm ocean caused us to have one of the warmest winters on record. And so it wasn't exceptionally dry, but it was really warm. And so a lot of what would normally fall as snow fell as rain. So the snowpack. Snowpack is how we store water in the Northwest, right? We don't have very big reservoirs. We have lots of snowpack that melts. And there was horrible, horrible snowpack. It was the lowest ever that anybody had seen. And so you ended up with hardly any water in the rivers, and what water was there was warm. And it's really interesting, since then, they have changed the way they regulate the Columbia. Columbia has all these main stem reservoirs, and so they've actually come up with ways that they can get water from the deep parts of the reservoirs that's colder and try and cool off the river. And in fact, I think they started doing that in 2015, and it was too late after they'd already told it. And parts of it they can't regulate, but like Dwarshak is this massive dam in Idaho, and they can actually drop the temperature of the Columbia, the main stem, by, I think it's like 5 degrees, but if they release water from the right places. And they've now also spent, I don't know how many millions of dollars, so that the ladders, the fish ladders going over the dams have colder water. So they're changing where the intake is for those, just to protect that. So it's a huge deal. And it was kind of, nobody saw that one coming. And yeah, it was unfortunate. Somebody over here had a question? Yes.
There are indirect effects of the blob, the heating conditions on the fish populations. For example, increase in parasites with disease or something.
Where's Kim when you need her? I would imagine, I mean, that's one of the big concerns of climate change is physiological response. And that, you know, fish are cold-blooded, so the warmer the water, the higher their metabolic rate. And especially with cold-water species that are getting up towards their lethal limits, they're certainly going to be more susceptible to parasites, disease, perhaps predation if they can't swim as fast as normal. The other thing is that nothing happens in isolation. So at the same time they're being stressed, suddenly you've got these warm water predators that are up here, right? That are doing fine because they're in their preferred temperatures. So it kind of clashes. But yes, we expect that. And certainly that picture that I showed you of the sockeye, and they had these big old nasty bacterial infections on it because they were in the warm water. Yeah. So not good. Yes. Other questions? Yeah.
Are there folks across the Pacific that are seeing changes related to the blob on the other side of the...
You know, it's really interesting. So I went to a salmon meeting in 2015 in Japan, and there were Japanese salmon biologists, Korean salmon biologists, Russian salmon biologists, Canadians and Americans. And the Canadians and Americans, all we could talk about was the blob. And the Russians, the people on the western side of the Pacific were scratching their heads going, what are you guys talking about? It really wasn't warm over there. It was mainly this side. Since then, they have been getting warmer water over there. And in fact, they are starting to see, I don't have that. They have been seeing warmer water, and the Japanese are very concerned about it. So you can see, I mean, over here, you know, it's cold for the most part. The Bering Sea has been really warm, but we got this big thing kind of coming out here. And the Japanese, they released a lot of chum salmon from their hatcheries, and the last couple of years, the water's been so warm by the time they release them, which is the same as it's been for the last 50 years, it's too warm, and they're having big die-offs. Yeah, so that's, the fish don't get a chance to get up north, which is where they go into the cooler water. So
Where there is no more cooler.
yeah. And so they're starting to see some crashes. It's not clear what's going on with pink salmon, which is the big population in Russia, just because it's hard to get information on what is happening over there. But most of this was really, appeared to be an Eastern Pacific issue, less so a Western Pacific. Although certainly, like the Bristol Bay populations, we think they're mainly up in both the Bering Sea and then up in kind of this area, out the middle. And they seem to have been doing okay throughout most of this. The idea generally is that around here, if it gets a little bit warmer, it's not good. We're stressing things. If you get up in Alaska, it gets warmer. It increases productivity. Yeah. So, but it's, you know, some things do great, other things not so much. So it's really mixed. Other questions? Come on, guys. You got 5 more minutes.
No, there's none online either. So, any announcements then, I guess? Huh?
I have a question.
Yeah.
Is this presentation going to be available on the website somewhere so we can review
It's
it?
being recorded.
It's being recorded, and we'll be releasing it on the HMSc Pass seminar web page.
Thank you.
So, do you know what?
I usually try to get them up on Friday, as long as I have permission.
Yeah. So none of this is my own data. The disclaimer is kind of, a lot of it is from websites, like all this stuff. Go to this website, you can download all the pictures you want, and it's public, most of it's publicly available, and just kind of knowing where to go or knowing who to talk to in some cases. But, yeah.
Great presentation.
Thanks.
Just have one quick announcement. If you haven't seen the posters or flyers,